Hello and welcome back to another episode of A to B. Where we last left off, we finished learning about the keyword once, allowing us to do many a cool trick with the language. Now we're going to move on to the next stage in our adventures, which is the proof of turn completeness. I don't think we're proving it, although it wouldn't be too hard to prove it. Maybe there is a proof given in the message. I just noticed A to B is Turing complete. We can simulate the probe of Turing machine with a special letter and represent the tape with a string. Given this property, A to B can handle any solvable problem as long as you don't consider its efficiency. In other words, it can perform all tasks in the scoring criteria. Here we can use arithmetic operations as an example. Okay, I don't think there's much more here than I've already done, but oh. Proof of Turing completeness. Here we go. Given a Turing machine with states, the alphabet, one of them is the tape alphabet, and then the other was the input symbols. Okay, there we go. Oh, it says it right there. That's the transition function. Initial state, accept, reject states. Yeah, and as I said before, all you need to do is use the once command once, and then you have a Turing complete language. Just like that. Which is very neat. It's this one, I think. I think I just showed my background. Yeah, I don't think there's anything sensitive in the background. What's blinking? You're blinking. Don't blink. I'm gonna close you. Okay. Let me fix this. As always, whenever I do that, I mess up my entire screen. I hope this ends up with the teacher reluctantly agreeing to accept the language. Alright, we're gonna start with count. Input: a binary number. Output: that many A's. Okay. So this is gonna come down. I assume we're just gonna use a minimum number of lines. I have an idea. So we're gonna start with a number as input. Then we're gonna start once. We're gonna end equals. We're gonna end with a single B. That's gonna represent the number of things we need. 0. B is equal to BB0. 1B is equal to BB1. No. What do we need? ABB1 maybe. Well, then we're also going to need 0a equals a0. 0. We've already hit a little roadblock. But I'm recording this, so I could keep going. Oh, it's a full disconnect, yeah. Since no one's here, I think I'm just gonna keep going. Okay, it's an offline recording. Haha. 1a equals a1. Okay, we're back. The gaming servers just got updated. Wait, is that why I get random disconnects? Because my computer just does something random and disconnects OBS on purpose. Oh, you dick. Is this actually why it's happening? Which would explain why I get bad performance during the evening. I'll deal with this after stream. Son of a gun. It just tells me, oh, I've updated something in the background while I'm supposedly disconnected. Okay. So this will, like, push everything to the side, and then once we've reached the end, I mean, we can write end. Or we could just write 0 equals nothing, 1 equals nothing, equals nothing. So this will work. We can do it in one fewer line. Intriguing. Okay, different approach. One becomes a n for a different kind of one. Okay, and then, or maybe na. And what we're going to do is we're going to do a0 equals 0aa, a1 equals, oh no, a n equals naa, like that. Or we can transform it into a 0. Aha. Surely this won't work. Oh! We found a solution in just 3 lines. Hey, hey! Score! We're better than you. Cool. I suppose then I have to update all of the previous... whatever. Min plus lines. Okay. A plus 1, a binary number, input plus 1. Ooh, this is... Oh no, this is easy. Once equals end. We'll put a character n. 0 n equals 1. 1 n equals n1. No. And 0. Start n equals 1. There we go. So we start with 1. If we reach a 0, we get a 1. Otherwise, we carry the 1 over, basically. Easy peasy. Alright, proof of Turing completeness. If you've taken formal language course seriously, you should have noticed your so-called programming language is actually a string rewriting system, not something new. People have been working on it since the dawn of computers, and you act like you are completely unaware of that. On the bad side, it shows you have the same poor attitude towards other theory courses. On the good side at least, it proves that your project is an original work. I can't agree with your attitude, but you do have some ideas of your own. I can say that you have talent, but you struggle in class like people who lack talent. It's a waste. I'm actually struggling to talk a little bit because I burnt my mouth eating spring rolls. And as a result of that, the top of my mouth hurts when I touch it, like I constantly you know, put my tongue up to the roof of my mouth too many times. Which sucks, but I'm gonna use water to cool it down a bit. 5-3, A plus B. Input, 2 binary numbers separated by a plus. Their sum. So we can combine the 2 previous solutions together. Let's do that. Because I'm lazy. And apparently, this game is powerful enough to do that. Okay, we changed the ends. Okay, there we go. It's... Does that work? No, it doesn't quite work. Why does it not work? Oop, press the wrong button. Aha! Because of this line. Okay, so in hindsight, this doesn't work. But at least we tried. Okay. In seriousness, how should we actually do this thing? Actually, the idea of doing that isn't so bad. So we have our 2 ends like separated. So now we have basically n. Oh yeah, now we can delete the 0, do the plus, and now we just convert this bunch of n's into a number. Simple. once equals start 0. No, wait, that'll delete it immediately. We can't do this method actually, because this thing is going to delete our output immediately. Haha. Haha. That's best in me. Okay, we can't, we have to use a completely different methodology then. Something that uses the plus as a way of like making sure things go all right. Probably we should add the first number to the second number rather than the other way, because that's the easiest. So start plus equals nothing. So just delete it. Just so the idea is we're gonna erode the start until we have nothing left. Now, how do we solve this conundrum? Maybe something like plus becomes n plus, maybe. And then we send it to the back, but the issues, we might run into issues. Is there maybe a way of like scanning the pluses through? Maybe like once we do like plus equals n plus 0 n. So we use the same method as I did before. Like nn0, 1n becomes an0, an1. Or actually we can just do nn, right? No, we need to keep all the numbers. Ann1. Then what we do is a becomes end m. Okay, my microphone hasn't gone off. And then we do the counting thing. We can just copy and paste count this, or the +1. Not count. Wait, except we replace everything. Actually, I'm gonna replace this start by end. Okay, and then at the very end, we just start deleting all the characters in front of the equals. Why can't I press? There we go. Okay. Why do we keep running into issues? Yeah, so the 1, maybe plus? No, if we do plus n... Oh no, we can do plus n. Plus n equals plus 1. There we go. Okay, what's the issue here? So we did 1, so this should become 11. So it's becoming 0. And then it's becoming a 1 and 11. Oh wait, okay. So it is 1 and adding two n's, so that's correct. So what incorrect should be maybe the start. Wait. Oh, I shouldn't have this line. There it is. There we go. I'm 2 lines over. Okay. Okay, is there another way of doing it? I think we're still doing the plus. Is there a way maybe to do... No, because the issue is with start. If we were to do like start 1, start 0, this will erode the output. The whole point of this... Well, actually, I guess we could do once equals start Q. I guess we could do that. And then we can just do Q1 and Q0, but then the Q disappears. That's the issue. So we would then have to use messengers anyways. Let me not delete the code. I mean, place a different one. So what we need to do... Alright, let me review the previous code. It's either a completely different methodology, which I doubt it. I think the increment methodology is easy enough because it's only 3 lines. So we only need to implement the rest of this code in 6 lines, basically. Yeah, it's just this, excluding this line, which I don't know why got reintroduced. All we need is these 3 lines to use the count method, right? So all we need to figure out is to do the rest of this in 6 lines only, which I think should be doable. Wait, maybe there is a way. But that might still be too complicated. So actually, why did I do this? I can just type it in. Let's try it. Okay. Q1 equals 0AQ. Q0 equals 0Q. And then what we do is we do A0 equals 0AA. A equals end in N. Q plus equals nothing. We delete it, and then we do the thing. I suppose we have to do this at the very front. Oh, why is there 0 to start? I guess we just delete the 0. No, wait, that doesn't work. We need to do the other way around. QA. And we delete the 0 afterward. Okay. What went wrong? Ah, right. We need one more line though. Okay. But to make this approach work, we need one more line, which is unfortunate. Basically, we need the line start 0 equals nothing. Then it will work. But now we still use one extra line. Is there a way to remove that one line? I hate that it almost works, but it doesn't. Is there maybe a way of doing deletes instead? I think that would not work either, but the basic idea is that we increment on one way and then decrement the other until we reach like satisfaction, but I don't think that works. That would be way too complicated. Man, this one's not trivial. I think something using this method would work, but I just need to refine it a slightly bit. Q1. I think maybe this method is always doomed to fail. Yeah, the queue has to be ahead to transform all of the ones into zeros. That's the important part of this algorithm, which makes it work. Without it, I don't know. Maybe it doesn't need it. Hang on. Q1 equals QA. Q0 equals Q. A1 equals 1AA. A0 equals 0. No, that still takes 10 lines. Because we still need to delete these ones and then send. We still need 10 lines for this. Or it doesn't even work. And once again, I can't use like start one because otherwise it's gonna lead to issues. It has to be in place. Okay, let's try a different approach. We start with an A. A1 becomes... Maybe we can do something like that. Hang on. It's always guaranteed to be at least one. Yeah, we can't do like one start one equals. That's silly, but I wish I could. Yeah, we can't do like once start one equals A. We can do once equals start Q, Q1 equals A. For instance. A0 0AA. A1 equals 1 AAA. Would that work? I don't think so, right? I mean, it worked for 11. Does it work for, let's say, 101, which would be 5? So we start with an A. So A01 becomes AA01 becomes 6. Yeah, it doesn't work. What if we did 0 instead? Oh, that actually works. Oh, I mean, that works. Ah, right. That's the issue. We still need to delete all the zeros at the start. Oh, man. So close. Again, with 10 lines. We are so close. If only I could condense this into one line. But it won't let me, right? Yeah, it won't let me. Ah. Maybe there's a way of correcting it. So it will always start with I mean, I can correct it in 2 lines, right? Once AA equals A. That'll solve it. But it's the same solution, right? It doesn't... I mean, actually, it doesn't even solve it, maybe. I suppose I would have to do AAA. Comes A. Yoink. So many different solutions, but they all take 10 lines. And I need to find one that has only 9. Harumph. Harumph. Okay, let me try a different tactic. I don't know if this will work. We will start with a Q again. Q1 becomes end B, maybe M BA? I don't know. M equals start Q. Q0. Hang on, let me type it out first. Maybe this MB. So the idea is the B is going to duplicate and the A is going to, or I should write N. Except I don't think it's... Yeah, we need 3 lines again. Q plus equals nothing. B equals... Bn equals NB, NNB. And then... if we NB, we got nothing. Once again, it's 10 lines. It didn't even work. Aha. Guess we could put that at the end. I don't know why I'm debugging a solution that doesn't even work. I guess because maybe it might work. Oh, we need to NB. Wait, that's not working either? Oh, N. No. B. Wait. Oh, we need to flip it around. Ah, right. My brain. Yes, we flip it around. Silly me. It would be the other way around. It would be NB becomes BNN, and then B becomes 0. And then now it's still broken for some reason. Because this will only be 1. Oh, right, because I didn't flip these ones. Sorry, BN. I unflipped it again. Okay. But back to this. But it's still not correct. Okay. Once equals Q. Maybe does transforming it into different symbols help? Maybe Q1 equals... maybe not 0, but like O. A. Q. I don't think it would help, but... yeah, it wouldn't help. Right. Because then we would still need to do Q plus equals for this to work. Maybe this method's doomed. I can't think of any way of making it shorter. We might have to try a different method. Like maybe... okay. Maybe I have an idea, but... so what we do is we do... no, we can't do that. Ah, because then it will reconvert. It would have to be once Q. So once Q equals 0, Q1 equals 0AQ. Okay. We'll just have that traverse. I'm such an idiot. Hang on. I just realized something. I had the solution correct. There's no way for me... maybe there is a way for me to retreat all the way to the back. No. You know when I said, oh, I wish we could just do something once? We can. Because it's going to be the leftmost one that we want to change. So we can just do the one... I'm such an idiot. I'm such an idiot. I had the solution right in front of me. Okay. All right. Okay, let me show you the actual solution. I had it right in front of me. We can just do once 1 equals A. A1 equals 0 AAA. A0 equals 0 AA. A equals end A. Then we do I guess we could do 0 plus equals come on, plus and then plus equals nothing. There we go. Oh, sorry, end. An N. We wanted an N. There we go. I literally wrote down the solution, except I was like, oh, we can't actually write start because we can't combine characters. But of course you can do that. You just don't need to put the start character. Obviously. Idiot. Alright, I'm doing an audio test quickly. Sorry, the music is gonna go off. Okay, sounds good. Okay. A minus B. Two numbers separated by a minus. And then we need to get their difference. Now that is a very challenging puzzle. Is it guaranteed the first number? Okay, yeah. So we're guaranteed a positive number. We don't have to deal with negatives yet. If ever. I accidentally turned that off. I wouldn't want to do that. Oh, and also I need to keep that open so I can see notifications. Okay, that's not dilly-dally. Man, do I still have to figure out how to do negatives? Okay, let's import the previous solution. Maybe, so, and then we'll try to convert this into negatives, which I think we should be able to, but okay. And so 0 negative becomes 1 negative, and 1 negative becomes 0. Is that what we want? I don't think so. Maybe that's what we want. So 1 0 0 becomes 0 1 1. And then we delete the starts. Actually, we can save a line. Aha. Oh no. I don't. So this should be. Oh, we did 1 minus 11. That's why it didn't work. Ha 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 ha. Okay. I guess we'll do n1 becomes, or maybe we do the same thing as before. Once n1 becomes this, 0 0 becomes 0 minus minus. Oh wait, no, then they'll combine. There we go. We have to keep it for now. 0. Or maybe negative? We'll just implement it directly. Wait a minute. Maybe I could have saved a line or two from the previous program. I'll double check it, but... Okay. So we have all the negatives lined up. And now... Oh, I guess not really. Equals negative. So we delete all the zeros. We then need to convert all the n's into m's, which will be important. And then we delete this. We delete the negative mark. Yeah, this is important. And then we do the deletion, which will be, as I said, 1m is 0, 0m becomes m1, and then start 0 is deleted. There we go. So we just convert the last ones into the number of m counts, and then we at most 8 lines. This is infuriating. Because I feel like it could actually be done in 8 lines, but it might be the kind of thing I do it by direct conversion. But like, what we do is we do like instead of 0, we do like maybe a different character, D, for doubling, and then ND just does the same thing, DN, N. Oh, that doesn't even work. Doesn't even work. Oh, right. This would have to be lost for this to work. But not even. Okay, let me return back to the original code. And 1 equals 0 and an n. And turns to m, we delete the m. We'll delete all the zeros. Finally, we delete that. And then we do zero n equals n1. 1n equals nothing, or no, sorry, 0, and then start 0, nothing. Sorry, this should be m's. Okay. Is there a different way of doing it? Maybe scan it the other way? No, but scanning the other way Also doesn't work, right? I mean by starting at the end. Okay, what I mean is we start with that, and then we go 0n equals n and 0. One n yeah, that doesn't work, does it? I feel like we need to use a different quirk somehow. I mean, I can think of a complicated way of doing it, but I think it does take up more. I think it does take up more than it needs to. Once and 1 equals a. Once minus 1 equals minus a. A0 becomes 0. A1 becomes 1 A minus a becomes minus. Oh, sorry. What I have it done? 0 A. Then we need start start 0 equals nothing. 0 minus. It must say, and then but then how do we convert it back to a number, right? That's the issue. We have to convert it back to a number now. Once we're done with this process, we'll have like a minus. Yeah, this method doesn't work, does it? Is there another way, maybe? No, we can't use end. That won't work. I mean, we can do once. But we can't use end 1 or end 0 because that will destroy the output. The issue is like end or like 1Q is that we need to keep the Q, so I feel like if we try something like that, I was thinking of making jumping the end to the front kind of deal. So like, so once end it with Q, then we do 1Q equals, I don't know, M AD or MDA, something like that, and just AD becomes DAA, and then we go backwards somehow. Oh yeah, and M becomes end Q. So that will get us almost there. Okay. Now it's basically, so if I were to run it once, look. Okay, that was not the output expected. Oh, start. And then 0Q. Yes, it's gonna have this structure, but it's not useful. It's not useful. Maybe it's a different way. Maybe like -1 equals A D minus. -0 equals D minus. DA becomes ADD. No, sorry, AD. And after all of that, we delete this and the minus, and then we just go as normal. 1A becomes 0. 0 becomes a 1. Start A becomes 0. Does that work? Oh, sorry, start 0 equals, what am I doing? Start 0 equals nothing. I suppose we need to do the other way. DA, and then if it's AD, we become DAA. That makes more sense. Oh, it works. We did it. We found the solution. Can I take this as an affirmation? More importantly, did I pause? Sorry, I had beans for dinner. I think it's getting gassy. Two binary numbers separated by a star. Okay. Interesting. My instinct is to turn both of them into a list of A's. And then just multiply the two lists of A's, because that's the easiest way of doing it. In my opinion. It could also be the wrong way of doing it, actually. Wait, maybe there's an easy way. Okay, let me grab the code to convert. Yeah, wait, so doesn't this mean that there's a cheaper way of doing a... Because that's a very similar code, right? Then we just go 0A becomes 1. 1A becomes A0. Start A becomes 1. Okay, so yes, this one can be done in 8 lines. Just checking. Okay. There's a cleverer way. I guess kind of just because you do one of the other after the other, so they'll give you an easier time. Okay, I think we need to do something similar. So let me just copy and paste this code. So we now need to replace all these with a... Okay. So now we have a list of A's and a list of 1's. The point is we're going to multiply... Let's just get a solution that works, because I want to see the minimum lines. So what we're going to do... Zero A becomes A0. 1A becomes AAN1. Start A becomes 0, becomes nothing. We delete all the A's that end up at the start. Oh wait. I think we might need to do NA becomes AN. Yeah. Wait, this doesn't quite work, does it? This method doesn't quite work, because now we're gonna have a bunch of n's with 1s and 0s interspersed, and we need it to not be dispersed. I think it almost works though. Maybe what we need to do... I have an idea. What we need to do... N... just sends it to the back. Just sends an M to the back. And then once... we just do one N. So the idea is what we're going to do is we're going to do... So N is going to be the number of times we increment our number. Except what we're going to do is we're going to start with our original number. So that way we have one copy of it already. No, wait. We need to delete more than just one. In fact, we have to delete 1A. So around the very start, basically. At the very start, we need to delete 1A. And then we do this process. Zero M becomes 1. 1M becomes M0. Start with M becomes 1.
Did you get up today?
Okay, we can't use this method because we ran out of space. Fair enough. That was probably gonna happen, considering we are trying to multiply two numbers.
Or did you take it away? Life will lead you in the right direction if you let it. Pause and take a second. I promise that you won't regret it.
If there was an easy way to expand it into a sum, it would be nice.
All we have is here and now. All we have is here and now. All we have is here and now. All we have is here.
There's a bug.
All we have is here and now. All we have is here.
Maybe there is a way. Hang on.
All we have is here. All we have is here.
Okay. Hmm. Okay. So that's our list of... Oops, sorry. Then we delete the starting zeros. Maybe maybe there's a different way. I mean, let me think. A way of doing this so we don't have to run out of bits. I mean, in theory, we're always wait. If we're trying to multiply two numbers, 31 times 31, that is 900. It's always going to exceed the limit, so we can't represent our output by like individual characters. So that's always going to be a limiting factor. So we have to basically do it in place, is what I'm gathering. Yeah. Maybe after this. So once we've got all the A's, we'll place an like a delimit thingy sign. Let's make it the $sign at the very start. And what we'll do is we'll send all of the things there, and then we'll sum them together, basically. So what we'll do is we'll do so 0 star just becomes maybe M star. M becomes end in a 0. So that multiplies the ending number by 0. And then what we'll do is we'll do 1 star, N star, N sends the number 0D, and what D does is 0D becomes D 0K, maybe 0K sends the 0 to the start, like that. I would do the same thing for 1D, D1K, 1K, so you send the start to the 1. So what this has done is we have multiplied our number by 0, at the back number by 0. Oh, I guess we want to put this the other way around. D0. There we go. And then we've sent the number to the front. And after, I guess when we've reached star D, will become star E. Oh wait, we don't want to destroy the number. This destroys the number. K becomes D1L. L certain. Okay. And then E. Ooh. Oh. It's sending it to the wrong place. No wonder. Okay, let me stop the recording quickly. And we are live. Let me test the audio. Music's gonna go away for a moment. Sounds good. Yeah, I was recording to the wrong folder this entire time. Because my previous setup was on a different profile that I changed, so it recorded everything to my C drive instead of my D drive, and my C drive is almost full. Which is a slight issue. Anyways, I should be dumping the rest of it into the D drive now. On the flop side, don't know how long I've been recording for. Let's hope it's not too long. I think after I'm done with this chapter, with these few challenges, I think I might have to stop for today, because I have a busy day tomorrow. Okay. So this will set everything up properly. Oh no, we don't need to do this. Oops. We need to do this. No, we are trying to be destructive. Okay. Wait, so why does this not work? There should be... Yeah, that definitely didn't work. So I'm just trying to set it up so it should say 10 plus 10,000, I think. 10 plus, it should say 10 plus 10 with 2 extra zeros. 1,000. It should say 10 plus 1,000. So why did it not happen? Okay. 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 Ah, they're doing it out of order. Yeah, no, K's have to go first. Oh, and I also deleted that by accident. I think it's fine if they... Maybe it's not fine. Maybe we have to make the D's do their magic first. I'm not sure the exact order I need to do things in. Maybe I think I definitely need to do this first. First, and then we do everything else. Oh, and then the E. Something. I don't know what I've done. I've changed the keyboard by accident. Give me back my... Don't think it matters. Okay, okay. I think I messed things up again. So I think these ones have to go first. Right there. In fact, these have to go before. And then this one just has to go at the very start. Then we do these things next, and then finally we do these ones. Okay, we have this set up. Then what we'll do is we'll do $sign plus 1 plus $sign. Plus. Same thing for 0. So we'll just delete the back input. So, delete the back. Alright, then I guess we should delete this one. Okay. And now we just have to do this, which is... Can we just use the same code as for this? Not this one. I don't know I don't think we can, but... Don't know if this will work. Delete the first one. So then these A's will start absorbing immediately. So this will delete the first one. So now it's the second one that we're starting from. And now what will happen is... Wait, I don't think this will work. Huh. Hang on, go back. I'm seriously considering transforming them all into A's and then just adding them up together. That would make my life easier, but I don't think it'll work. Oh. There is a way, actually, maybe. So what we'll do, at the very end, we'll write this. And then we'll write the necessary code. Maybe like an XA. A1 becomes 0AAA. A0 becomes 0AA. X equals nothing. 0. Then we do 0 becomes 1. 1A becomes A0. Start A equals nothing. And then oh yeah, we need to once something. Okay. Is it actually close to terminating? No, not close at all. Because of this, yeah. Right. That's why it didn't work. Oh, it didn't work for several reasons, actually. So all of these will become A's, and then we need to add the A's together. Except it also won't delete them. So it'll actually be a bunch of x0. This will first turn, so running up to here will turn it all into x0. A. Maybe we need to first do x0 equals x, xa equals bx, and then we need to do x equals 0. And then here we do b. Oh, and we're supposed to do b equals 1. Okay. Okay, this is actually working. Except we reached the string label again. Okay. So this approach doesn't work either. Ah. It has to be a native solution. It has to be something we can... Yeah, I'm definitely overthinking it by a lot. Huh. Okay. I do still think that the approach of writing it out as a sum first may or may not be the correct way of doing it. Kind of like an invariance of sort, but maybe I have to add it directly. Because the issue is that I can't write it immediately as a sum. Okay. I have an idea that might work, but I think I might again hit the string limit because I'm again writing it as a list of A's. I don't know. I think eventually I have to do that, but I want to limit it. The idea is going to be once 0 this. Oh wait, hang on. Equals. And to be explicit, start. Okay. And the idea is what we're going to do is we're going to bubble things through. So what I mean is 1 will become maybe D, like that. It might have to be AD. Okay, let's do AD. Let's do 0 first. The 0 case is easy. The 0 case, we just want to double the thing at the very end. So maybe we need to do okay. So I'm just gonna write it down. D1 0D becomes D0, and then star D becomes 0 star. I don't know why I say star. $0. So that just multiplies it by 0. Now, if it's a 1, we first want to add. So it should just be a D. So we do AD star. And AD is going to work the exact same way as before. It's going to be 1A becomes... Oh wait, hang on. Zero, we can certainly... Oh, we have to do A0. And 0. And then 1A, we do AAB1. Then 1B becomes... Okay, we're doing it little... We're gonna flip the end bit. I think that's the only way to do it. That's the easiest way to do it. It'll save us a lot of time. One A equals AAB1. B is gonna be start N. And then we're gonna do we're gonna do the same thing as normal. N0 equals 1, N1 equals 0N, and then we do N dollar becomes $1. D constars 0, okay. And then, oh yeah, we need dollar A becomes just dollar. It's done its purpose, it's bubbled through. Okay. And that way we've incremented enough. Maybe we should put this thing. Yes, I think we should put this at the start, so we can do that as we go. Oh yeah, these ones should be at the end. There you go. Yeah, this one should even be forward. Yeah. I want to do these last. This. Probably in this order. I think we want to do D after we finished 1. Yeah. Oh wait, hang on. No, yeah, that happened. So D will happen after the A's are done, which is what we want to do. So B's will happen first, then will be the N's, then it'll be the A's, and then finally the D's. That's the order we want to do things in. And that should put the right number at the very start, up before the dollar sign. At which point if we've reached this point, now we just start deleting. And then we should be fine. Oh, then we still have a little endian, except that's also wrong. Hang on, we need to double check to make sure it's correct. So yeah, so now it's gonna be flipped. Wait, no, this wouldn't be little endian. This would be big endian, right? I don't remember which way is which. Also, it wouldn't be either, because Indian, these are, you would do that with bits, not with single, with bytes, not with single bits. I'm getting all my terminology mixed up. I think we're getting to the right solution, but I think we might want to do this first, actually. Because that would decrease the number of that would decrease the number of A's we will have in total. In fact, let me rerun this. So still output the same thing, because I forgot I have to reverse the output. I mean, I could take the fact that okay, so we have this 0, then we're so here, so after one cycle we should have 101 there. Let's see when the cycle ends. That's when there aren't any A's there anymore. There. We end up with 1010. Oh yeah, that's correct. Okay. So we will just delete the first 0. That should be fine then. Yeah, we'll just delete the first 0. So once 0 becomes the thing we need. We use the pound sign. Then we need to flip the entire input. Okay, pound 0 becomes, I don't know, what letter should we use? K. K0. And we need to do this first, I think. K equals start 0. L equals start 1. 1 equals L. Pound is done. Okay. Son of a gun. Okay, fine. We'll use a different one. No, let's not use exclamation. W. We'll use the letter W. Okay, works. Look at this. We might hit the limit, but so be it. Please don't tell me the correct solution has like 10 lines, because I am double over. The wait is excruciatingly long. Fingers crossed. Oh, the model solution has 8 extra lines. Yes! Yes! Yeah. So, a week ago, on stream, I solved this problem, but I didn't quite explain it properly, nor did I put comments down. So, that's what I'm going to do now. Let me hide my facecam first. So, the idea is that we're going to be intermittently storing the result in the form 0a $B times c, where result is always going to be equal to a dash times 2 to the power of k plus b times c, where a dash is the reverse of a in terms of like the string. If we reverse the string of a, we will get a dash, and then k is the number of digits in c. So it looks complicated, but very succinctly, if we had a string of the form, say 0, 1, 1, 0, dash 1, 0, 1, dash 1, 1, that will be equal to, so we remove the first, 0, then we just have 1, 1, 0, which is 6. Oh, sorry. A dash is 1, 1, 0. Maybe we should put a 1 here, just to... So we remove the first 0, and then we reverse the string to get 11. And then we have a dollar sign. 101 is 5 times 11 is 3. And then our number, the resulting number that we want to get is 11 times, well, there's 2 digits here, so it's going to be 4, plus 5 times 3. And the idea, how we're going to work this, is we're going to be bubbling each of the digits of C through B, and then adding it to A. So what I mean by this is, say we start with our 11 plus 5 times 3. We're going to be bubbling it through so that eventually it becomes, so 11 plus 5 times 3 is the same thing as 11 plus 5 times 2 plus 1. What we're going to do is we're going to add 5 to our number. 5 plus 11. Dollar sign 5 times 1. And then after this bubbling through, we'll then multiply it by 2. So we'll get 16 times 2, 32. And then if we keep going that way, eventually we'll get the correct number. So in this case, it'll be 37 times 2, except times 2 is just equivalent of adding a 0. Yes, I guess we could do 37 times 2. So 37 times 2. However, that's equivalent to adding a 0. And as I said, we're going to be removing the 0 at the very end, which will divide by 2. Trust me, this algorithm works. And if you... Oh, I forgot to remove these from the previous recording that I failed. Oop. If you need to trust me, you can run this. Okay. See, it works. So, how does this program work? Okay, we go here. So here, okay, let me, oh, I didn't disable my, okay, whatever. So how does the program work? Well, at the very start of each loop, once we have it in the correct form, what we're going to do is we're going to start bubbling through digits of C through B to get to A. Now, if it's a 0, that is effectively the same thing as multiplying by 2. So remember at the very top, we have our string of the form a dash times 2 to the... Does the dash show up? Yeah, it does show up. I could probably just do this. So remember how our result was always of the form a dash times 2 to the k? If the leading digit in C is 0, that doesn't affect B times C if we remove it, but it does affect this thing because k is the number of digits in 0 and we're reducing the number of digits by 1. So we need to multiply a dash by 2, and that's effectively the same thing as just adding a 0. So that is what D does. D just adds an extra 0 to make sure that our a dash is the correct form. Now if we do a 1, we need to basically add a b. The reason we do this is because if we add a b to our a dash, it will, let me show you this way. Yeah, if we add a b to the a dash, it will add it around here. And that basically means is that it's going to get multiplied by 2 to the k effectively, which is exactly what we want. So if we take an example, (17 to the 5 times, okay, actually 5 times 2, which we'll express as 10. What we'll be doing So there is an extra 0 at the very start. Maybe I should... Okay, actually, I'll write it down as a string. That might actually be better. Let's not use 17. Let's use 1... So 0, 1, 1... No, let's just use a small number. So this is 5. 1, 0, 1 times 1, 0. So what's going to happen is... So this is a 5. This is 5. This is 1. What we're going to be doing is we're going to first bubble through this 1, which will add a 5 to our number. And it's going to add a 5 here to the reverse of this number. So if you can imagine it, this is actually 10 right now. So we're going to add 5 to 10. So 1, which is going to make it 1, 1, 1, 1. 101 D. We still haven't added the D yet, and then it's going to be a 0. This D is going to add a 0 to the end. And then with this, we're just going to use this to add another 0 to the end. 1, 1, 1, 1, like that. Times nothing. And the reason this works is that this is our invariant is going to maintain. By which I mean, here, what do we have? We have 5 times 4, which is 2 to the power of 2. There's 2 digits here. Plus 5 times 2. So that is 30. Now when we transition, this number is 15, I think. So it's 15 times 15 times 2, 2 to the power of 1, that's 1 digit, plus 5 times 0. Okay, that's 30. That's perfectly fine. And then here, we have 0 digits, so this is just going to be this number, which is 30. 30 times 1 plus 5 times 0. Which is the number we want. We want 30. Okay, if you can spend a little bit of time to fully understand what we're doing, but all this is doing, if there's a 1, we're just adding this number to this number. Of course, this number is reversed, and the digits are reversed. So this is the ones part, this is the tens, this is the hundreds, this is the thousands. So we're adding this number to this digit, and then we're multiplying by 2. And if we do it this way, we maintain our invariant at the very start, the one that I specified at the very start, which is how we ensure that the program works as intended. Now, how do we do this? Well, very simply, A bubbles through. So A, what A is going to do is it's going to bubble through this digit B. Every time it passes a digit, it multiplies by 2. So effectively, only one A will pass through this digit, but there will be 2 A's that pass through this digit, and there'll be 4 A's that pass through this digit. And that means that every time we pass through a 1, we generate a B, and that B will add to our final digit. All B does is it adds 1 to the first digit, like that. And then once the A's reach the $sign, then we delete it because we don't need it anymore. So this will allow us to bubble these A's through this second digit to add this number to this number, and then we multiply by 2. Okay, perfect. And so once we're done with this process, what we end up with is the number that we want with a trailing 0, and then a bunch of junk that we can delete. So we first delete the junk, and then we reverse our A. We reverse our A to make it in the correct form. So here is where we finally delete the trailing 0, and then we use these we use these commands to flip our digit. And that's that. Oh yeah, and one thing I forgot to explain is that at the very start, we initiate our number in the form 0 dash b times c, where in this case b times c is the input, is what we start off with. So this will be correct, and so because this is 0, this a dash will be 0, and so our final number will be b times c. So that's how we make sure that we get the final result properly. Now we're dividing. Oh, that's not fun. And remainder. Ooh, that's even harder. It's not a perfect division. Oh, buddy. That is tough. Tough. Okay, we're gonna go over time. Probably. We're definitely already over, because I think I started more than 2 hours ago. Okay, so that's what I'm doing today. I'm not gonna have enough sleep tonight. So sad. Okay. So when I did the minus, if it overflowed, what happened was that it would end up with a list of n's representing the number of representing how much I went over. So maybe that's the solution, is to do it that way. We convert the second part to a list of n's representing the number of times we subtract. Then we perform a subtraction at each time until we reach a list of n's. At which point we count the number of n's, and that's the remainder. That's good. I guess we can try this approach. We'll see what we end up with. I don't know. Okay. How do we begin? We convert the second part to a list of n's. So it's once becomes n, I suppose n, and 1 becomes 0 and an n, and 0 and 0 becomes 0 and n, and we'll do n 0 becomes 0? No, just division. Okay. So that'll give us our list of n's, the one we really want. And now we begin a loop. How do we do the loop? So maybe now we have to introduce a character that constantly exists, and as long as the character exists, it does something. So maybe what we do is we do divide becomes a different character. Maybe the... Oh wait, is that supposed to be for comments? I don't remember what the character for comments is. Oh, I think it's is it which one is it again? Hang on, I'm changing it back to your keyboard. Which one is the one? This one? I don't remember which one was one for comments, I'm gonna be honest. Is it double? No. Okay, I'm gonna use... Just to be sure, we'll use that one. I don't think this one's for comments. I can double check. Oh wait, I can just press this button. And just for myself, I'll see the list. Hashtag. AKA £, or the... What's the cool name for the Chrissy Crossy boyo? Chrissy Crossy boyo. £. Not the sign for the pound. No, not that one. Number sign. It's... It had a cool name. Hang on, where is it? Names. Octothorpe. That's it. Octothorpe. This one's the Octothorpe. So cool. Anyways, I can't use it, so. So while this exists, I guess we'll make it equal this. Where D becomes NE? No, maybe not. We'll do this. I guess what we can do is we can do DN becomes NMD, where after all that's done, D gets deleted. Or XMD. Be fancy. Use fancy letters. After we delete it, M becomes N. Like that. So we'll scan through. Do that way, so it'll send all the M's back to the end. And then what we can do is we can do ampersand X becomes X ampersand, I suppose. And then we delete. How do we delete? Simple. 1x equals 0. 0x equals x1. And that's it. Right? Oh, I guess also we need a character to start. Maybe no, we can do start 0 equals nothing. Okay. Right. Obviously this was not gonna work. Let me see. No, okay. Because we didn't remove this condition. We keep going. Until it's completely empty. So it's 1, becomes a 0. I think we need to do this... Wait, which order do we do this? So it's... Yeah, definitely this first, I think. Maybe we need to... I think we need to do this second. And then this one last. So it immediately deletes, as soon as it creates the leading 0, it deletes it. So we don't end up with this thing happening. That's important. It's not usually important if the number to subtract from is bigger, but in this case it matters. Okay. So then what we will end up... So normally, if it goes through, the number to the left will be nothing. So we'll do x, this, d. Oh, actually, we'll change the symbol. We'll change the symbol to maybe... Oh, that. Okay. That is not the number expected. Wait, at all? Hang on. That... Oh, I forgot to count. I forgot it every time. Oh, we should probably keep all the D's at the end then. We shouldn't delete any of the D's. Except at the very end, we should turn the D's into... Oh no, we do need to delete the D's. But we need to do it in a stylish way. We need to keep a record somewhere. Maybe at the start. So before all of this, we bring back our favorite symbol. Ah. Where is it? Damn you, keyboard that doesn't have the symbols on it. N. No. A. Oh, we need to do 0. 0. Oh no, we could use this symbol immediately. Of course! Of course! Silly me! Silly me, silly me, silly me, silly me. Okay, let's delete this line. Um, are we doing little endian again? No, I think it's easier to just do 0 equals... Oh. A0, 0A, A1 equals 1A, A dash equals B dash, 0B equals 1, B equals B0, start B equals 1. Okay, in which case we have to modify this one to be 0 dash equals dash. Okay. And then here, if we end up with x, we need to use a different symbol. We'll use the we haven't used this symbol yet, so okay, but this number is definitely wrong. Why is it wrong? That's why it's wrong. Oh, I suppose I need to delete one instance of D. Or 1A, basically. Once A equals nothing. Okay. Oh, wait. Now it's still wrong. For a reason. Okay, let me check the loop. So 1, 10, and an n. Is that correct? So that is 8 minus 3 is 5. That's minus another 3 is 2. Wait. Yeah, that's definitely wrong. Oh, no, that's correct. No, that's correct. That's correct. Because I do it one more time. Ah, I see. Yep, I get it. I get it. What we need to do is we need to do x ampersand n. We turn that into ampersand. And then whatever, how many n's we have left, that's what we convert into the number. Once... Oh wait, no, sorry. The other symbol. Keep using the wrong symbols. Once. And then... Why did that not work? Oh, wait. Oh yeah, B doesn't work the same way. Oh, we do need to use a separate symbol. Oh, the shame. C. Maybe we don't need to do this. We can incorporate it. Oh no. We can't have this. Oh no. I just realized if there is no remainder, we have to put a 0. So we can't have this line. Oh no. It almost works except for that one issue. No. We have to replace the ampersand with something else. Not the ampersand, the code. I can't use words anymore. Ampersand is a different character. I have actually forgotten what that mark is called. Wow, my brain is really falling apart today. In fairness, it is 4 in the morning where I currently am, because I inhaled a bunch of coffee before. Comma, that's what it's called. Oh my gosh. Okay, we need to replace this by a different character for now. Okay. Got it. Alright, where were we? That 0x becomes x1, that's correct. I think this is the one time I should probably document the code. But am I gonna? No. Okay, there we go. Figured out where I am. 0c equals 1. 1c equals c0. Comma c equals 1. Comma 1. And becomes a comma, otherwise this just becomes a comma. And oh, actually we could just do, oh no, we need to do comma 0, there we go. Otherwise this just becomes a comma, and we just do this. Okay, we figured it out. Except we didn't figure it out. Why is that? There we go.
Yo, change that beat up. Here we go.
Please don't tell me that I need more. I mean, considering multiplication was 28 and this is only 2 extra lines, surely their implementation of divides is more complicated, because it is a more complicated formula. Since we have to also deal with remainders. I mean, I could probably figure out a place to reduce. This is taking a long time. I'm gonna check my emails. Ooh. We had 40 lines to do this in. Incredible. But yeah, we've done it. We've done it. All right, so I explained multiplication. Now it's time to explain division. So, for the most part, our string will be of the form a dash b at m, where for input k divided by n, so that's this thing up here, m is a list of n's, and a plus 1 times n plus b is equal to k. We're not reversing any digits this time. So first, this part. M is a list of n's. That's exactly what we're doing here. We're literally just we're just taking our second input and making it into that many n's. So in this case, this is 3, so we just make 3 n's. Now, why do we do this? Oh yeah, we're setting it up into this form where a is 0. Okay, we'll explain it later. Now, why do we do this? Well, what we're going to be doing each time is from each n, we're going to be creating an x and an m. The x is how we're going to subtract from b. So b is going to be the number that we currently have. And then each time, each loop we perform, we are going to subtract 1n from it, and then we're going to add 1 to a. So, what we're doing, we're spawning an x, and we're spawning an m. Okay? The m's are just going to become an n again. So this is how we make sure we don't destroy the n bit. The m is just going to become an n, but we just need to do it this way to not have the n's then make another x when we don't want it to. The x is how we're going to subtract our number n from b. And very simply, we just do it the standard way. Here. So the x will interact with b to subtract 1. Furthermore, notice we have a d at the start of every loop, which is, I think, there. At the start of every loop, we create a d. The d will bubble through the n's, the list of n's here, which is the m, to create our m and our capital M and our capital X. And then at the very end, when it's reached the end of the list, it then becomes an a, and that a adds 1 to our digit a. Okay? Then we do all of this, and so as a result, what has happened? We've added 1 to a, and then we've subtracted n from b, and that maintains this equation, which is exactly what we want. Now, eventually, we'll hit a point where our number b is too small for us to subtract n from. At which point, we're gonna have x's left over. So if we subtract like normal. If we can subtract 1 from our b, then our b will be 1 less. However, if the b is empty, so if it's nothing, the empty string, now we're just going to start accumulating x's. And the number of x's that we accumulate is equal to how much over we've gone. Effectively, it's the negative, it's a negative b. So right here, so the b is now negative, so the number of x's is how much over we are. So if there are x's, then r plus n is now our remainder. And that is precisely why we insist on having it in the form of a plus 1 times n plus b. Is so that eventually we're going to be over by 1. So this a is going to be, so a plus 1 is going to be 1 too many. So that's fine. Because then what we're going to have is going to have a times n plus b plus n, right? These are equal, right? We just remove the 1 from this equation and we add it to b. And as I said, because b plus n is a remainder, as I said all the way to the bottom, because if we go over, that's what we're going to get, then our a is going to be the correct value. So we don't have to do any gibber-gabber to a. So the number of x's we're going to have is going to be the remainder, how much over we went. And so all we need to do is we have x, we're going to have x percentage. And remember how we had a list of n's at the very start? All we need to do is we need to cancel out the x's and the n's until we just have the n's left. And that is going to be our remainder. We then transform that list of n's into the number, and then we just remove all of the gobbledygook. Okay, and how we set this up, remember we want it of this form. The first time we do it, we just so the first time we do it, what do we do? Right, the first time, so we just set it up, the first time we just set it up as 0 dash b times b at m, I think. Yeah, which is not in the correct form. That would definitely be wrong. However, the first time we add 1 to this initial number, we don't do it, and so that's how we get our a plus 1. Of course, this has an edge case where if our initial number m is bigger than the first number, we are gonna need to adjust it properly. Yeah. And I think I do this adjustment somewhere. I just don't remember exactly where. Oh, right. So the first loop, when we delete this part of the code will happen at least once. So the first time it'll be of this form. However, once we've done it at least one time, then because we've deleted the first time we add 1, so this number will then be correct. That's it. I remember that. Okay. And that's the program. Cool. Back to you, Lucas, to do the outro. See ya. First try, baby. All right. Yes, you passed. If this is all you care about, so be it. Go to waste your talent on whatever you want, and don't bother me anymore. Looks like there's more stuff. Let me just check quickly how much time it might take. Oh wow. You may not use keywords. I think, okay. I don't have time today. I think I might do a hybrid stream for the final episode because I don't have enough time. Well, this is not going to take me 2 hours to complete. Did they change this? I mean, okay, it's I already figured out how to do the first one. Yeah, it's not gonna take me 3 hours to do 2 hours to do this chapter, so I'm gonna try to figure out something to do tomorrow. No, I'm not gonna do tomorrow. Tomorrow I'm playing chess. Friday is when I'm next gonna play this game, so I'll figure out something to do. I guess I'll just make 2 videos there, and the first one I'll just finish this one quickly, and the second one I'll try something new. Another like fun thing to do, just to pass the time. Oh, I hope no one actually followed me. No, okay, because that window was closed the entire time. Okay, I think there's not much more for me to say, other than I need to go to sleep because, as you can see already, or if you heard, I'm already breaking apart at the seams mentally. So with all the things we have done, gosh, thank you very much for joining me. I hope you have a wonderful day, and I hope I see you another time. Goodbye.